Alright guys, let's crank out latitude at LAN. Lesson 10 is on the drive. We're gonna hit lesson 10, and then lesson 2 is the same thing but different problems, and then part 3 is a LAN with side reduction. So it's more steps to it. We're not gonna go over it. I don't think we're gonna hit this anyway in class. But here are the steps that I followed anyway right here. So let's crank out lesson 10. We're gonna so just read this. We're gonna crank out this problem, but we are, because it has more stuff, it has more steps than the one that we were given in class. Here's how you go about it, but this is the one that we did in class, and I number the values because the problems that we have up here, they provide you with your DR positions that you're gonna need. So your DR positions here, and we're gonna solve it, right? So we were given our initial latitude, the one in the morning at 0542. So the values that were given to us was our course and distance. I mean our course and our latitude 1, longitude 1. We were provided with our times, and we were provided with our course and our speed. That's what I think was on the board. So let's crank out. So the first step is just to see what your course angle is. Our course angle was 300. Ooh, let me charge my computer. So our course angle our course was 300, so we're going north. So we have to just from the get-go realize that we're going up. So the value that we get, which is this, is obviously higher, right? And this, since we're going west, it has to be higher as well. We're going 300, so 360 minus that 300 gives us our course angle of 60. That's the first step. Second step, we gotta find our distance, right? So DST, 1220 minus 0542. The 20 is less than our minutes here, so we have to change this into 11 hours and 80 minutes. I did all the math yesterday. This is the third time I do this video, so I'm not even gonna bother doing the math because I know it's correct. I'll just show you where the values are coming from. So 80 minus 42 is 38, and 11 minus 5 is 6. We can now work with the minutes, so we have to make that into a decimal. So the 6 hours, so the 38 divided by 60 becomes a 0.63, and our distance is going to be DST. You guys do 60 district, that's fine. I just remember that I have to do it to the T. So 9.8 times 6.63, 65 miles. The third step is the way that I set it up. I put L1, L2, longitude 2, and then this would be blank for now. This would be blank. There's a difference in latitude, difference in longitude, and our mid latitude. So we're gonna go to 4. We're gonna find our L, and is distance cosine of course angle, which is 65 miles, cosine of 60. Our course angle gives us 32.5. It goes in here. We know we're going north, so it has to be higher. You're gonna add it. Becomes 27, 14.5. 32 plus 42 makes this go to 27. And the rest, it's I think it was like 80 something or 40 something, I don't remember. But anyway, now we're here. From there you can get your mid latitude. So just add them and divide them by 2. And you get 2658.5. 8. The 8th step is getting our P that we're gonna use on our DLO equation. And if you think about it, like, you have to remember, like, what are you trying to get? Our DLO, right? So we gotta find P. That's how we found P. Cosine of ML, we had this already, so we solved it right there, right? So our P is our difference in latitude, tangent, course angle. So 32.5 tangent of 60 becomes 56.29. Oh, sorry. So we got 56.29 divided by the cosine of 26.97. Remember that we cannot work with degrees and minutes. Remember that this has to be a degree. So we took the 58.25 and we divided that by 60, which became the 0.97. And what we end up getting is 63.16. It goes right here, which is the same as 1 minute. 1 degree, 3.15 minutes. And we add that. We're going west, so we're going to add it to that. There it is. So now we have this, right? So now we can start, right? But we're going to work on the first one, right? So go ahead and read number 1, and we'll, pause as you want. So the values that were given, we're just going to chuck them into our template. We got our lat, we got our long, we have our date, we have our HS, dip correction, we have our index correction, and lower limb. So let's start cranking this out, right? So the first thing that we are going to do is we're going to open our nautical almanac, and we're going to go to July 22nd. I think it's... a little too far. So by my book, we are going to July 22nd. And one thing that you have to remember, I don't have it on here, but I have it on here. So remember that if you have, if you guys have if your longitude, your DR longitude is west, is going to be the same, so just drop it down. And if it's east, you got to take the 360 minus our longitude, right? So I think we did that on this problem. Yeah, we're going to do it in this problem. So this one is west, we dropped it. But the one that we're going to solve is this one. So it was 359 and 60. We did the math, so 359, 60 degrees. We took this off from that, and we ended up with 301.01, right? So we're here so far. Now we gotta take that 301 and 1, and we gotta go to July 22nd, and we gotta see where it fits, right? It fits right in the middle of here, right? So we got 8 hours, 9 hours, right? So it's in the middle of it. What you're gonna do is you always go up, right? So 298.24.7, 298.24.7. Then we are also going to get our declination, north 20, 16.4. We put it right here, our declination, north 20, 16.4. And we took our D correction, which was 0.5, and it's going down, north, north. See, it's going down, so it's negative, right? Now, we had 301.01. We got from the book this value, and we're going to subtract the top one from the bottom one. The difference is 2. So we put the 8 hours here, sorry. And then we did that math, and we have a difference of 36.3, right? So now you're gonna have to take that and convert it into minutes, right? And I didn't teach this in a video because it's not worth it to teach this so far, but I'll teach it now because it's super simple. So you have to go to the arc of time, right? So conversion of arc of time. Here we have degrees, right? Here we have minutes. And we ended up having 2 degrees, right? So go to the 2 degrees. 0 hours 8 minutes, 0 hours 8 minutes, and then 36.3, right? 36.3. So okay, so we have 0.3, right? It's gonna be closer to this 0.25, right? Um, if you're in the middle, I think you have to interpolate. Don't quote me on that, but it makes sense to say that. I think. Don't quote me on that though. So we're gonna go 36.3, which is the second column right here, 36. So 225, right? 225. Add them both together. It's 10 minutes 25. 8 hours 10 minutes 25, right? Now in license, I think some questions will just ask you for your zone time of LAN, so that's why you finish here, and that's why this is set up the way it is. Uh, and what you would do is you'll take your zone description, which is 58 divided by 15, and it's gonna be, if I recall correctly, it's like 3.8. Remember, we have to round, so it becomes 4. But for here, and if it's east is least negative, but on this step we're gonna reverse it, right? So we're gonna add it, which is at 12 hours 10 minutes and 25, right? If they were asking for zone time of LAN, this is where you're gonna finish, but they're asking us for our latitude of LAN, right? So you're gonna drop this down, yada yada. We ended up here, these values were given, right? And remember, index correction is on, if I recall correctly, so it's negative, off is positive. And our dip was 20, right? So let's solve this side right here real quick. Let's go to the top. Dip correction was 20 feet. 20 feet, it's right here, 4.3, right in the middle. Remember that it's negative, so it becomes negative 4.3. Apply those corrections, this 2 to this number. Now we're here, and then we're gonna go to July, right? Same page, July, and we are 79.37. 79.37. So we're here, and it's lower limb, lower limb. Okay, remember, April to September, from October to March. So we're here and lower limb, right? Uh, we're right here, 15.7. So 15.7, and we applied that to this value, and we ended up here, 79, 53.3. Do the math, and you'll see that everything is working out, right? So now we're here. Now you apply your zone description again. Now we go back to where we were at 8 hours, 10 minutes, and 25. Apply your declination, or not apply. You have your declination that we got from the book, 0.5 that we got from the book. It was negative because it was going down. It was north 20, then north 19. And then we're going to go to our index, our tables in the back. And it is 10 minutes and 25, right? So we're gonna go to the 10 minutes. That's 40. 10 minutes. The correction of 0.5 is 1. So it becomes 0.1, right? It was, 0.1. So it becomes this. Apply that. You get your declination. I'm not that great at explaining this part. But it'll kind of make sense. So we have to remember, it's 90 minus your HO gives you your zone description. So we got this already. Bring it down. Do the math. 89 minus 79 is 10. 60 minus 53.7 is 6.7. And we have our declination from here, 20 and 16.3, right? Now remember, our latitude is 10 degrees, right? Our latitude is 10 degrees. How do you know if you add or subtract? I always remember that if I add both of them, I'm going to be at 30, which is not where we are at, right? In the general vicinity. So our DR has to be relatively close to your final answer. So you subtract it, right? So 20 minus the 10 is 10, and 16.3 minus 6.7 is a 9.6. That's the way that I remember. Try to reach your DR latitude. And that's how you do these problems. I'll do Polaris soon. All right.